Hello! For this Purdue MET211 project, we were given the task to place a beam of material and support that beam by our choice of counter-levered, supported at both ends, or include overhangs beyond supports, creating a statically indeterminate beam. For our project, we chose to place a beam made of 01 tool steel measuring 1/2 inch high by 1 inch wide. For our support, we chose to load the beam in an arbor press where the supports are 5 inches apart. The force is applied directly in the middle of the supports. The arbor press has a tundicator located at the top, so we know how much force is being applied. We also used a spring-loaded indicator that was positioned directly under the load cell. This allowed us to measure the amount of bend applied to the beam. We will now demonstrate our project by applying the force to the beam. Here you can see that 1/2 ton equals 13 thousandths of an inch bend. After recording our results, we then proceeded to add more force to the beam. Here you can see that 1 ton equals 17 thousandths of an inch bend. We then repeated the process and recorded our results in increments of 1.5 tons, 2 tons, and 2.5 tons. Here you can see that 2 tons force equals approximately 37 thousandths of an inch bend. At this point, we were given the press about everything that it could handle, and that was approximately 2.5 tons force, and we got approximately 64 thousandths of an inch bend. This concludes the experimental phase. Now, let's see if the theory marries up to the experimental results. By using the formula in Appendix A19, Case A, we can derive our expected results. By solving for I, all we needed to do then was fill out the rest of the formula using length equals 5 inches, I equals 0.0104 inches to the fourth, and for P, the incremental load. After solving the equation for the different loads, you can see on the graph the differences in the theoretical bend versus the actual bend. The orange line on the graph represents the theoretical bend, where the blue line represents the actual bend. So why the difference? Our team concluded that this may be due to the fact that the equation is calculating a fine point where the force is applied to the beam. In our experiment, this wasn't the case, as the force applying apparatus was approximately 1 inch in diameter, so this would apply the force to a larger surface area, skewing our results. But if you look at the percent of error per incremental force, the percent is pretty well consistent. This concludes our project. We hope you enjoyed it.